This video will be the first of two on something called LeChatelier's principle. LeChatelier is a person who described what would happen to an equilibrium if you disturbed it in some way by adding something or removing something or raising the temperature or compressing the container's volume if you have gases and so on. And so let's go back to this equilibrium that we've looked at. And the H2 and I2 are in equilibrium. That means their forward and reverse reactions are the same rate. Now think what happens to the rates if you add more product. Well, if you add more product, all of a sudden the reverse rate is greater. And that means the reaction now, instead of being equal in both directions, is now greater in that direction, which means the reaction there will be some net reaction now that takes the product and converts it to reactants. Okay, so in the end, what happened was if you add HI, the system responds and lowers the concentration of the HI from what it was when you bumped it up. Okay, and the other thing you can look at is what happens to the equilibrium constant. Okay, if you all of a sudden add HI, then the number in the numerator is now greater than it would be when you calculate the equilibrium constant. And so it means now it's no longer Kc, it's a different number. And the reaction will occur, and eventually a new equilibrium will be established where the new concentrations of all three, when you plug them into here, now give you the same equilibrium constant as before. So the K is a constant, but not necessarily individual concentrations. So you can have many, many different concentration combinations that give you the same number. The converse happens as well. If you remove HI, now the reverse rate is slower than it is at equilibrium, and that means now the forward rate is greater than the reverse rate, which means the net reaction is in the forward direction, which means some of the product you removed is now being made by the reaction. And so again, what you did is kind of ameliorated or responded to by the system. You add something, the system reduces its concentration. You remove something, the system makes more. Okay, so we're going to extend this principle to another example where we also include heat as one of the stresses on the equilibrium and also changing the volume of the container.